Okay, we want to make our third program in Google Apps script for our waves thing. We're going to go down to the last program we made, the standing waves, and we're going to click on the little arrow, and we're going to duplicate this one, and then we can rename it, and we're going to call this one our oscilloscope. Our oscilloscope. Okay, and then up here we can call it the oscilloscope. Okay, there's not a lot we have to do here. We're gonna, instead of being time-based like the last two problems we were, where we had something, a y value versus time and another y value versus time, this is not going to be time-based. We're actually going to take the one wave, the y values, and we're going to graph it versus the y values of the other things to make our Lissajous figures. So we don't need to add these two waves anymore. So this whole column, column M, we can just delete that column. Another thing we want to do is we want to make our time interval even smaller. We want to kind of get through at least like 2 cycles of the wave. Right now we did 1 divided by 360. So we divided basically one wave into the time into 360 parts. Instead, we're going to divide it by 720, so we can get like 2 cycles of the wave in. That'll help us a little bit. And then, so I have to fix my time column now. So this will be J2 plus I2. That'll still be right, I guess. But we're going to drag this down for like a lot farther. So we're going to go all the way down to 720 something. Let's see, that was 362. So we need to go like to 722 probably. There's an easier way to do this, I just don't remember what it is. 722. And that did not work. I messed up all the way up. Great. Okay. So I had 0, and then we had J2 plus that, and basically I needed to take this and copy that down. That's just great. See, I wonder if I can just scroll all the way down to what I need to do and just do shift. That doesn't work. Yeah, I should have known better. Okay, here we go. Starting over. All right. Just scroll down and deal with it. By now, I'm sure you've Googled the way to do this faster. There's some kind of secret trick. I can't remember what it is. There we go. So we ended with 1 second. That's good. I'm really glad that happened that way. Okay. So then, so wave 1. If we look at wave 1, this will be our X signal. I'm going to put X signal, which is wave 1, and this will be our Y signal. Okay, so this, I'm going to put that over here, X signal, and this is the Y signal. Okay, and for our X signal, we have the normal equation, amplitude times the sine of 2 times pi times C5, which is the frequency, times J2, which is still the time, plus D5. Yeah, that's the phase, and we got to put it into radians. Okay, good. All right, this one, we should have the same thing, except for the other, the Y signal. I think that's all good also. Okay. So what we're going to have to do, though, is we're going to have to come down here and get these equations and take them on down to the end. Okay, well, looks like that's going to work. Okay, and so what we're going to graph, I'm just going to delete this table. What we're going to graph is the x versus the y. I can do this a little faster, I think. Just shift and hit it. Okay. That's good. Insert, let's see, I need to be up at the top, I think. Insert a chart. We want a smooth line chart. Customize, chart style, background color, we're going to use black. Chart and axis title. The chart title we're just going to call Oscilloscope. Grid lines, don't really want any. None. None. Okay, we're just going to have a nice oscilloscope here. Series, for a regular oscilloscope, is kind of a really bright green color, so that's kind of cool. We'll do that. Okay. Good enough for now, I think. Let's see. Let's try some things here. Let's make this be 90 degrees, and there we go. So the amplitudes are the same, so I should have really basically a perfect circle. So I'm going to kind of bring it in like that better. Okay, yeah, so if I did the amplitude different, like on one of these, then I guess that didn't change anything. Interesting. Thought that would squash it or make it different, but I guess it's not for some reason. Okay, so if they're equal, if they're 180 out of phase, then it's a line going up the other side. 270 out of phase, then it's a circle again. We're only going to deal with this phase. We're just going to leave this at 0 all the time because we wanted the difference between the phase, so that's totally fine. What if I had a frequency of like 2.5? Well, see, now it's my x is, so if I put the box around this thing, I have 1 point of tangency for my x and I have 2 for my vertical. So my vertical, or my y, is twice my horizontal. So instead of x signal and y signal, maybe I should have put h signal and vertical v signal, but that's up to you on how you want to do that. Okay, let's see. What we want to do is we want to kind of maybe rotate this Lissajous figure. So it's time to go into our program. See what we got here. Okay, so I actually want to come here and let's make a copy. And then we'll rename, call it oscilloscope.gs, our Google script here. This is my oscilloscope program. I'm going to do a function. I'm going to call it Lissajous. That's the name of my function. Okay. I'm going to go back over here. If you remember, let's see, where'd my button go? There it is. Right click on that, move it down a little bit more. Oops, I'm running the script somehow. Oh, it's because I clicked on the button accidentally. Okay, so it's doing something kind of weird. Cancel that. Okay, I am gonna right click on this, and you might want to change your button to say something else like start or something, but assign script, and we want to call it Lissajous. You got to spell it exactly right, so we better check. Yeah, L-I, okay, good. Okay, so we get the active sheet. We are going to deal with a phase. So I'm just going to call it var p. We're not going to ever change the other phase. We'll go ahead and set this one to be 0 at the beginning. Sheet.getRange, is it D5? Oh, let's see, I'm going to come back here. I gotta change some things here. That's 0. Let's make that 0. Okay, so this is D5. So we're going to sheet.getRange D5 set value of that to P. I won't need this one anymore. What we're going to do is while P we're going to do it this way. While P is less than 360, we're going to change P from 0 up to 360, which basically means we're rotating it around, one time. So while P is less than 360, let's see, P sheet get range D5 get value, good. And then we're going to take the P and reset it to P. We're going to add like 10, plus 10, we'll say. We don't need that one. Sheet get range D5 set value to P. Okay, and then we don't need this other one. We're not going to do anything to other phase. We're just dealing with the phase change between them. So I set a variable of P equals 0. I put it in the D5 range. And then while P is less than 360, which it is right now, it's 0, then I'm going to get the range. I'm going to get the value. What's in there would be 0. I'm going to add it to 10. So now my phase is 10. I'm going to put the 10 back on the sheet so it rotates it. And then it's going to come around here again, and it's going to get it. And it's going to add another 10. So now it's going to be 20. It's going to put that back on the sheet. It's going to keep doing that and running, basically spinning the Lissajous figure. So I'm going to save that. And then I'll come back over here. And I should be able to click propagate. And there it goes. So you'll see my phase change between them is going up by 10 every time, and it rotates it, kind of rotates the image around like this. If I had a frequency here of 5, then I'm going to have, got to the end, so I'm going to propagate it again. So it's going to be like a diagonal line, and then it goes to a circle, and then another diagonal line, and then it'll go back to the other diagonal line, and that'll be a 360 degrees phase change. It's changed all the way around. Okay, we could do some other things. I could do like a 4 to 3, something like that. There we go. We got a 4 to 3. So my Y signal is 3. There's 1, 2, 3 verticals and 1, 2, 3, 4 horizontals. 4 to 3 ratio there. I could do 2 to 1. So I got 2 horizontals and 1 vertical. I could do 1 to 2. And now I have 1 horizontal and 2 verticals. I could do 3 to 2. 1, 2, 3, and 1, 2. Or I could do 2 to 3. So I got 1, 2, 3 verticals and 1, 2 horizontals. And you can always propagate it and kind of rotate the Lissajous pattern, kind of rotate it around if you'd like. Okay. All right, so there is your very own oscilloscope. You can change different frequencies and figure out kind of how to read them, because you're definitely going to need to know how to read these things through the next couple of Jedi trials. That is our third program in our COVID-19 wave programs sheet. I think we'll probably maybe make a couple more programs, but we won't do that till Unit 7 when we start talking about sound. But we'll add a couple more tabs here maybe and do a couple more things maybe on that. So hope you got all those programs done, and hope you watch all the videos that I've shown you and get prepared for the Jedi trial on Friday.